Welcome back. This is lesson 27.4. We've been learning about hash tables, and in this lesson we'll create our own program which allows us to locate data in a hash table. In this lesson I'll show you an example hash table with some data added to it. You'll add code to search the table to locate search terms, say whether they're there or not, and we'll briefly deal with the problem of collisions and rehashing. So first let's load an example program. If you're my student, this program is provided on the Moodle. If you're not, I'm going to show you the code. You can stop the video and type it in for yourself. If you're my student, you'll find a program called Hash Table Search Program on the Moodle. Find that now, open it and look through it. Pause the video while you do this. Here's the code from that file. If you're not my student, pause the video now and open Python and input this code for yourself. This code creates an empty list of 100 storage locations and generates 10 random numbers, placing each number in its correct hash location, and then prints out the table so you can have a look. The code also includes the following lines of code which allow the user to input integers which will be search terms for our program. You can see I've used exception handling so that if they enter a value which can't be converted into an integer, the program stops. Otherwise it will repeatedly request them to enter search terms. Obviously we haven't yet written the code that will search for the numbers in the table. So now we're going to write the code to find the input values in the table and to tell the user if the value is in the table or not. In a hash table, the user will enter a search term. The search term will be hashed, that is, processed to generate an integer hash value, and then we'll look in the table at that location and the data will either be there or not. So this is what the code looks like at the moment. The user can enter search terms. Now we're going to convert the search term, the number, into a hash value. And we do this, we've already discussed this in previous lessons, by dividing the value entered by the user by the size of the hash table and taking the remainder, the mod value. This is the hash value. I've stored it using little I. That's the name, the identifier of the variable. So the hash value is I. Then we can look in the table at that location. So the table's called myHash. So myHash position I. If that equals the number that we're looking for, then it is found in the table. Otherwise, it's not found. If this was a function, we could return true or false. So stop the video and add this code. You can then run the program to see if it correctly locates items in the table for you. This illustrates the advantages that we've already discussed for hash tables. To find an item in the table is a single operation. The big O value is 1, or constant complexity. We don't need to look through all the locations in the array. This makes it much faster than a linear or binary search. But of course there are disadvantages, and we've discussed this. The hash table must have rather a lot more storage locations than there are data values. Otherwise we get collisions. So let's look now at the problem of collisions. Collisions occur when two data values result in the same hash value. Remember that data values are stored at a location generated by the hashing algorithm. But two different data items might have the same hash value. That means they would both need to be stored in the same location, and that's called a collision. Collisions become more likely when the table is too small and there aren't that many spare storage locations. So here's an example. We already looked at this in previous lessons. I've got 6 memory locations. I've already stored the values 12, 1004 and 99. Well, supposing I wanted to store the value 200. Let's hash that. 200 divided by 6 divided by the number of storage locations is 33, remainder 2. It's the remainder value that we need. So 200 should be stored at location 2, but there's already a value there. If we stored 200 in that location, it would overwrite the previous value and that data would be lost. We obviously don't want that. So we use a rehashing algorithm to find an alternative location. And here my simple rehashing algorithm just counts through the available storage until it finds an empty space to store the value. Because we're using rehashing, we have to take this into account when we look for data in the table. So we take the data and we generate a storage location using the hashing algorithm. We go to that storage location. If the data is there, then we can conclude that the value is found. And if the location is completely empty, then the data is not in the table at all. But what if we go to that location and there's another value there, not the one that we're looking for? Then we need to use rehashing to find out if our value is somewhere else in the table. Let's see how that would work out in code. Here's the existing code. We generate I as the remainder. That's our hash value. And we look in location I. And the number's either there or not. However, if the value is not the number that we're looking for, and it's not an empty space, then we need to start using rehashing. And remember, I'm using very, very simple rehashing. I'm simply adding 1 to the value of I. So that will count us on until at least one of those two conditions is no longer met. And at that point, we should have found our data item. So you can copy this code. I just want to point out another challenge for those of you who are confident programmers. If the value I in the while loop, we're simply incrementing I. If I reaches the end of the array, that is if I is equal to the length of the list, my hash, then we need to reset it to 0. So that's an if nested inside that while loop. So that's an additional challenge for you. Okay, so in this lesson, we've made a simple program that sets up a hash table containing integer data, and we've added code to let us find values in the table. We've also looked at how we could deal with collisions and rehashing. I'm going to leave you with some activities. You can copy the example that I've shown here to create a hash table that stores and finds number values and manage collisions using rehashing. You can simply copy the code, go back through this presentation and copy the code in your own Python program, or you could close the video and try and do it just from memory or from your own notes. And then finally, I'm giving you a larger challenge to really show that you understand hash tables. Create a new program that stores and finds text data, that would be ASCII or Unicode values, and you could allow the user to either input data or search for data. I suggest you create a simple menu, put it all into some kind of a loop. Okay, so that's a more ambitious target for those of you who are confident programmers. We're nearly at the end of the year now. Next lesson, I'm going to talk briefly about a final data structure, which is the record data structure. So bye for now.